Hi everyone, myself Dr. P. Soumya, working as an assistant professor in Department of Chemistry in Institute of Aeronautical Engineering College. So today I'm going to discuss about Introduction to Electrochemistry and Electrochemical Cell. In this session, I'm going to discuss about what is electrochemistry, types of conductors, types of electrolytes, what is electrolytic cell, electrochemical cell, and how to represent the galvanic cell. So first we should know what is electrochemistry. So I am making this electrochemistry divided into two words. Electro plus chemistry. Electro plus chemistry. So I am writing this electro as electrical energy. Electrical energy. This as chemical energy. Chemical energy. So electrochemistry deals with the interconversion of electrical energy into chemical energy and chemical energy into electrical energy. So what is the definition of electrochemistry? Electrochemistry is a branch of physical chemistry which deals with the study of conversion of electrical energy into chemical energy and also chemical energy into electrical energy. So the substances around us can be divided into two classes based on their ability of conduct electricity. So first one is non-conductors, second one is conductors. First one is non-conductors, second one is conductors. The non-conductors, those substances which do not allow electric current pass through them are called as non-conductors. The substances which do not allow electric current to pass through them are called as non-conductors or insulators. So examples of non-conductors are wood, plastic, glass, rubber. Examples of non-conductors are wood, plastic, glass, rubber. So whereas conductors are those substances which allow electric current to flow through them are called as conductors. The substances which allow the passage of current are called as conductors. So examples of conductors are copper, iron, gold, silver, non-metal like graphite and salt solutions. Salt solutions. So these conductors again divided into two types. Metallic conductors as well as electrolytic conductors. First one is metallic conductors, second one is electrolytic conductors. So metallic conductors are conductors which conduct electricity or electric current by movement of electrons. By movement of electrons without undergoing chemical change during the process. Without undergoing the chemical change during the process. So examples of metallic conductors are all metals and one non-metal, that is graphite. So in metallic conductors, conductors conduct the electricity by the movement of electrons without undergoing chemical change. So examples are all metals and graphite. Whereas electrolytic conductors are those substances which conduct electricity by movement of ions. By the movement of ions in aqueous solutions. In aqueous solutions. These does not conduct electricity in solid form. The electrolytic conductors does not conduct the electricity in solid form. So, in the electrochemistry, metallic conductors act as electrodes. Metallic conductors act as electrodes. Electrolytic conductors act as electrolytes. So, these electrolytic conductors does not conduct the electricity in solid form. So why do electrolytes not conduct electricity in solid form? Why do electrolytes not conduct electricity in solid form? So for a substance to conduct electricity, either it must have free electrons or it must have ions, free ions, which carry electricity with them. So for a substance to conduct electricity, it must either have free electrons or free ions, which carry electricity with them. So these electrolytes are neither have free electrons nor free ions in the solid state. Even though they are in ionic compounds, they does not have free electrons and free ions because they because the oppositely charged ions held together by strong electrostatic forces, so are not free to move. But when they are dissolved in water, the two ions split up and become free to move in the solution. Now they free to conduct electricity. Free to move, conduct electricity. Examples of electrolytes are sodium chloride, potassium chloride, sodium sulfate. So these, I am taking sodium chloride as an example. So this in solid form, it will have both sodium plus and Cl minus ions. Even though it is having ions, so it is both are held together by strong electrostatic forces. That's why here no movement of ions are there. No movement of ions will be there. That's why in solid state the electrolytes does not conduct the electricity. When these are dissolved in aqueous solution, means NaCl plus water, so it will split up into two ions, one positive ion, one negative ion. So when it is dissolved in water, sodium plus ions surrounded by water molecules, as well as chlorine also surrounded by water molecules. So between these two ions, electrostatic forces are decreases due to dissolution of sodium chloride in water. So because of that only, the electrolytes conduct the electricity in aqueous solutions, not in solid form. So types of electrolytes. Electrolytes divided into two types: strong electrolytes, weak electrolytes. Strong electrolytes, weak electrolytes. Strong electrolytes are those electrolytes which dissociate or ionizes completely in aqueous solutions to give constituent ions. Strong electrolytes are those electrolytes which dissociates or ionizes completely in aqueous solution to give constituent ions. Examples are inorganic salts like sodium chloride and KCl, strong acids like HCl and H2SO4, and strong bases like sodium hydroxide and potassium hydroxide. So whereas weak electrolytes are electrolytes which partially dissociate or ionizes in aqueous solution to give constituent ions. Weak electrolytes are those electrolytes which partially dissociates or ionizes in aqueous solution to give constituent ions. So examples of weak electrolytes are weak acids and weak bases. Weak acids like acetic acid, weak bases like ammonium hydroxides. So next topic is, what is electrode? Electrode is a metallic rod or bar or a strip which conducts electron into and out of a solution. Electrode is a metallic rod or a bar or a strip which conducts electrons into and out of a solution. So this is again divided into two types. One is anode, second one is cathode. So anode is the electrode at which oxidation takes place. So it sends electrons into the outer circuit. So anode is the electrode at which oxidation occurs. Oxidation means loss of electrons. Loss of electrons. Loss of electrons. So at this anode, loss of electrons takes place, means oxidation occurs. At cathode is the electrode at which reduction occurs. Reduction occurs. It receives the electron from the outer circuit. It receives the electrons from the outer circuit. Reduction means gaining of electrons. Gaining of electrons. So at cathode, gaining of electrons takes place, means reduction takes place. At anode, oxidation takes place. So what is electrolytic cell? Electrolytic cell is a device which can convert electrical energy into chemical energy. Electrical energy into chemical energy. So electrical energy into chemical energy. To explain electrolytic cell, we have taken here two electrodes which are dipped in the molten NaCl solution. Molten NaCl solution. So these two electrodes are placed in the molten NaCl solution which are connected externally by the battery. Means here we are applying electrical energy and we are converting this electrical energy into chemical energy. So at anode, oxidation takes place. At cathode, reduction takes place. So in molten NaCl, we have Na plus and Cl minus ions. Na plus and Cl minus ions. So Na plus ions, this will move towards the cathode. This will move towards the cathode and this will undergo reduction and form sodium metal. Which is deposited on the cathode. So at these chlorine ions move towards the anode with the loss of electrons, this will form chlorine gas by the removal of electrons. So what is the overall reaction here? Sodium plus Cl minus gives rise to sodium plus Cl2. So this is about electrolytic cell. So in this electrolytic cell, electrical energy is converted into chemical energy. So next one is electrochemical cell. This is reverse to the electrolytic cell. This device can convert chemical energy into electrical energy. So galvanic cells are electrochemical cells in which electrons are transferred due to redox reactions or converted to electrical energy. So redox reactions converted to electrical energy. Examples of this galvanic cell is Daniell cell. Example of galvanic cell is Daniell cell. So next topic is galvanic cell or voltaic cell. So this galvanic cell is made up of two half cells. So one half cell is called as anodic half cell or oxidation half cell. First half cell is called as anodic half cell or oxidation half cell. Second half cell is called as cathodic half cell or reduction half cell. So in first half cell, zinc metal is dipped in zinc sulfate solution. So zinc metal is dipped in zinc sulfate solution. So whereas in second half cell, copper electrode is dipped in copper sulfate solution. These two half cells, these two electrodes externally connected to the voltmeter by metallic wires. Internally connected with a salt bridge. connected with the salt bridge. So this is salt bridge is a inverted U-shaped glass tube which is containing concentrated KCl or ammonium nitrate in agar-agar gel. This salt bridge is containing concentrated KCl or ammonium nitrate in agar-agar gel. So this salt bridge is used for the electrical contact between two solutions. Electrical contact between the two solutions. So in this is zinc. This is first half cell. This is second half cell. In this, zinc rod is dipped in zinc sulfate solution. Copper rod is dipped in copper sulfate solution. So at anode oxidation takes place. At cathode reduction takes place. At anode oxidation takes place. At cathode reduction takes place. Means the zinc rod at first half cell undergo oxidation with the removal of 2 electrons and form zinc plus 2 ions. And it will give zinc plus 2 ion to the electrolytic solution. It will give zinc plus 2 ions to the electrolytic solution. So zinc is converted into zinc plus 2 ions, means oxidation is taking place at anode. So at cathode, copper plus 2 by reducing to the copper, it will undergo reduction to form copper by taking electrons. So the overall reaction of in galvanic cell is zinc plus copper plus 2. Copper gives rise to copper plus 2 plus zinc. So this reaction to overall reaction represent redox reaction. Means in this reaction, oxidation and as well as reduction takes place in one reaction. So at anode, zinc is converted into zinc plus 2 ions, and at cathode, copper plus 2 ions converted into copper. So in this diagram here, we can see zinc is undergoing oxidation and disintegration of metal is taking place. So whereas in copper is undergoing copper plus 2 ions which are present in this solution, copper plus 2 copper sulfate solution. These are undergoing reaction and forming copper which are accumulated on the copper rod. So next we should know what is the function of salt bridge. So this salt bridge is a U-shaped glass tube containing concentrated solution of KCl or ammonium nitrate in agar-agar gel. Contain porous part. So salt bridge is inverted U-shape glass tube which is containing concentrated KCl or ammonium nitrate in agar-agar gel. So the main function of salt bridge is to maintain electrical neutrality in two half cells within the internal circuit. So the main function of salt bridge is to maintain electrical neutrality within the internal circuit. So if salt bridge is not there, so I am taking 2 beakers and I am taking 2 electrodes which are dipped in 2 different electrolytic solution. This is zinc sulfate solution. This is copper sulfate solution. This is copper rod. This is zinc rod. So these are connected by voltmeter. But here I am not connecting salt bridge. So what will happen when salt bridge is absent? So in this anode, oxidation is taking place and zinc is converted into zinc plus 2 ions. Means in the electrolytic solution, the concentration of zinc plus 2 ion increases. Zinc plus 2 ions increases. So whereas at cathodic half cell, copper plus 2 ions which are present in electrolytic solution undergoing reduction and forming copper. So it means copper plus 2 ion concentration is decreases in second half cell. Means sulfur SO4 minus 2 ion concentration is increases in second half cell. In first half cell, zinc plus 2 ion concentration is increases. In second half cell, sulfur SO4 2 minus ions are increases. Means here positive charge is increasing, here negative charge is increasing. So first half cell positive charge is increasing, second cathodic half cell negative charge is increasing. So only it is takes place in the absence of salt bridge. In the absence of salt bridge. So if the salt bridges are absent, then the reaction will likely continue and the solution of one half electrodes will gather a negative charge, and similarly in other half electrodes will accumulate positive charge. First half cell, that is at anodic half cell positive charge increases, at cathodic half cell negative charges increases. So this will further result stoppage of reaction and no electricity will be produced. No electricity will be produced. It is only takes place in the absence of salt bridge. So what is the function of salt bridge? The salt bridge is having KCl or ammonium nitrate. KCl or ammonium nitrate. Means K plus, I am taking KCl solution, K plus and Cl minus ions are present in the salt bridge. So the salt bridge then supplies negative ions, means chlorine ions, to the oxidation half cell. To the oxidation half cell, means for anodic half cell, so we are having positive charge. At anodic half cell, we are having positive charge. So this salt bridge supplies negative ions. Salt bridge supplies negative ions. So from this, the electrolyte solution will be neutralized. Electrolyte solution in the anodic side, it will neutralized by the negative ions which are coming from the salt bridge. So in first half cell, the salt bridge is giving negative ions to neutralize the solution, and for second half cell it supplies positive ions to neutralize the excess of negative charge, present in cathodic half cell. Means at cathodic we are having sulfate ions, SO4 minus 2 ions. So salt bridge will supplies positive ions. Because of this, neutralization takes place. So the function of salt bridge is, it maintains the electrical neutrality between the two half cells. It will maintain the electrical neutrality between the two half cells. So this is a small animation about the galvanic cell. In this we can clearly observe that from the zinc rod, the undergoing oxidation with the removal of 2 electrons, and these 2 electrons accepted by the copper ions which are present in second half cell and converted into copper. In the same time, this salt bridge is giving negative ions to the zinc plus 2 first half cell, positive ions to the second half cell. So we can clearly observe from this animation both the work of salt bridge, function of salt bridge, as well as galvanic cell, how to it will be work. So the topic that is representation of galvanic cell. So to represent the galvanic cell, so we are having in galvanic cell anode and cathode. To represent, first we have to write anode on the left hand side and cathode on the right hand side. Anode in left hand side, cathode is on right hand side. So the anode of the cell is represented by writing metal first, then metal ion with concentration. Metal first, then electrolyte or metal ion of the electrolyte with concentration. First we have to write metal and then we have to write electrolytic solution or cation of the electrolyte solution with the concentration. The cathode is represented by writing the first electrolyte first with concentration, then electrode. Electrolyte first, then electrode. The two half cells, these two half cells separated by two vertical lines, that is denoted by salt bridge. So these two half cells are separated by salt bridge. So it can be indicated two vertical lines. So the value of EMF of a cell is written on the right hand side of the cell diagram. The value of EMF of a cell is written on the right side of the cell diagram. So first we have to represent anode at left hand side, cathode at right hand side. So first we have to represent, we have to write zinc, then zinc plus 2 ions, then copper plus 2 and copper ions. So this is the representation of galvanic cell. So the line which this vertical line is represent phase boundary. These two vertical lines represent salt bridge. So here we are having two reactions. First one is cadmium plus 2 plus zinc gives rise to zinc plus 2 cadmium. Cadmium plus 2 zinc and zinc plus 2 cadmium. Here in this reaction, cadmium plus 2 is converted into cadmium. In this, zinc is converted into zinc plus 2 ions. Means the cadmium is undergoing reduction. Cadmium is undergoing reduction by taking 2 electrons. So by taking 2 electrons. So this is acts as a cathode. This can act as cathode, and in this reaction zinc is converted into zinc plus 2 ions. Means it is undergoing oxidation. Means it will act as anode. It will act as anode. So first we have to write zinc and zinc plus 2 at left hand side and cadmium on the right hand side. So this is anode and this is cathode. So first we have to write zinc. To represent the anode, first we have to write metal, then metal ion. To represent the to represent the cathode, first we have to write electrolyte and then metal. So these two half cells are separated by two vertical ends, that is salt bridge. Two vertical ends, that is salt bridge. So another reaction is nickel plus 2 Fe plus 3 gives rise to nickel plus 2 Fe plus 2. So in this, nickel is converting into nickel plus 2. Fe plus 3 is converting into Fe plus 2. Means nickel undergoing oxidation, means it can act as anode. Nickel is undergoing oxidation, means it can act as anode. Here Fe plus 3, it decreasing the plus 3 to plus 2. Means it is by accepting one electron, it is becoming plus 2. So that's why means it means the Fe plus 3 is undergoing reduction and forming Fe plus 2. So it can act as cathode. It can act as cathode. Fe acts as cathode. So first we have to write anode first on the left hand side, cathode on right hand side. So anode is nickel, first metal, then metal electrolyte, metal cation of electrolyte, then Fe plus 3, Fe plus 2. These two half cells are separated by two vertical lines. Two vertical lines. This is the cell representation of equations. So From this, I am concluding this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.